5 to 10 seconds for everyone to join in. All right, I'm going to hit start now. Good morning, everyone. My name is Greg Tyrrell, Executive Director at AAUS, and welcome to this AAUS webinar. Today we're joined by Jackie and Nicola from Hover UAV up there in on the sunny Gold Coast. Hi Jackie, hi Nicola, how are you going?
Hey Greg, it's not so sunny today. It's a little bit raining, and we're adhering to restrictions, so we're both sitting outside. So we apologise for all the bird noise during this presentation as well.
No worries. Well, whatever it is, it has to be a lot better than lockdown city here in Melbourne.
Exactly. I was just having a look at the people that were on, and I do see some people from Sydney, so very grateful because now they've got their newfound freedom. I'm surprised they're jumping on a webinar.
Yeah, well, while we load up all the people, we're expecting a relatively large audience today of in excess of 150. So they're all joining it at the moment. Just before we to get started, I've got a slide up at the moment. Hopefully you guys can see that okay. Of some of our upcoming events over the next 4 or 5 months, or a little bit beyond that actually. Kicking off with today's webinar with starring Jackie and Nicola from Hover UAV. In the not too distant future, we have an annual general meeting for the association, and that is on November 18 for those interested. We're actually going to host it in Brisbane this year, given the openness of Brisbane, and our Brisbane board members will be attending that one in person, and for everyone else, you'll be able to attend virtually. On a Zoom link like this one. Late November.
Greg, I'm just going to jump in for a second. I've had a few people saying, oh yeah, I just want to check, can everyone hear okay from their end? If just 1 or 2 people can jump on to say if they can hear. Yep, perfect. All right, there's just 1 or 2 that can't, but I'm sure they'll figure it out.
No worries. The technology gremlins will get in from time to time. Hopefully everyone can hear okay. Yeah, just looking through some upcoming events. Wings over Illawarra is an event we're hoping to get to in late November. You know, restriction permitting, we might be at that event. We've got a networking event planned for the Friday night leading into that weekend for the Sydney Air Show. And we're also participating in the New South Wales Drone Expo over that weekend. So hopefully that one will go ahead. December, we've got another webinar planned with Wing Commander Kieran Joyce, who most of you will be familiar with. He's going to talk to us a little bit about Australian industry capability from a defence industry perspective. So some good opportunity there for industry with defence programs. And then looking into next year, our highlight, of course, is the RPAS in Australian Skies 2022, which we've just locked in dates for in March, late March, back in Canberra, back at Hotel Realm. So please look out for that one. So today's webinar, we're very lucky to be joined by Jackie and Nicola from Hover UAV. Hover, for those that don't know, are one of Australia's leading drone consultancies. Their core expertise is assisting UAV manufacturers, operators, and indeed end users to get their flight activities and drone activities approved and up and running and compliant with the regulation. The team have enabled both domestic and international clients to achieve complex approvals through their extensive knowledge base and regulatory experience. And today we're lucky enough to have Jackie and Nicola share some of their experience and knowledge with us today, talking about beyond visual line of sight operations, which is a holy grail for the drone industry at the moment, that has been quite difficult to get approvals to operate in that way. We'll hear some of the practical lessons and ways that we can hopefully make that a bit easier for you moving forward. Jackie and Nicola will talk for about 40 minutes or so, and there'll be heaps of time at the end for Q&A. There's a Q&A dialogue box in the Zoom window, which you can ask us questions. And the audience can vote up questions too. So if you see a good question that you want to hear the answer to, vote it up. And it'll rise up the list, hopefully, and we'll certainly have plenty of time at the end of the presentation to ask those questions. So I'm going to stop sharing my screen here and hand over to Jackie and Nicola to take it away. Over to you, girls.
Perfect. Thanks, Greg. We'll just share our screen for everyone. Make sure we can. Yep. Can you see that, Greg?
Yep. No worries.
Yep. Perfect. Well, it's so great for everyone to join. I can see there's so many people on the call, many with lots and lots of BVLOS experience, people from all around the world. I can see a fair few from New Zealand and definitely from Australia. As I said, some that I think are quite new to BVLOS and lots from the government and different departments as well. So this is sort of our take on BVLOS. So yeah, I mean, everyone does have different experiences. So we're hoping that you will learn a little bit with us today. So just really quickly, as I said, there's so many of you in the call that does have lots of experience. BVLOS just doesn't happen. And we do hear the term from CASA quite a lot, that crawl, walk, run approach. So you really need to have all of your systems in place prior to sort of starting BVLOS operations. So you need to, for those starting out, you need to have the correct licenses. You need to have the hardware and the software and be trained on it. You need to implement and have very good compliance management systems. Often I have seen with BVLOS, usually within about 6 months of getting an instrument, you do sort of start to get surveillance events by CASA. So it's good to sort of put all that in place as well. And also you can't do BVLOS in Australia without a remote operations certificate. Once you have those things in place, it then allows you to start doing the complex approvals. If it's extended visual line of sight, one-to-many, above 400 foot, remote operations, or any of the BVLOS as well. So just to quickly talk to you, in Australia, BVLOS is split into two categories. Extended visual line of sight, which is using a visual observer to check and clear the air risk, is also counted as beyond visual line of sight. In Australia, it's classified into Class 1 and Class 2. Class 1 is where the visual observer is sitting or standing right next to you, and that you can verbally communicate. And Class 2 is when the visual observer is up to 1.5 kilometres from you. One of the really good things that came in a few months ago was CASA did change the requirements for Class 1, which has been very good blessing, that now allows Class 1 people to operate without that instrument rating. We are going to talk about qualifications a little bit later. In Australia, it's Australia-wide approval. So it's really good. And you'll also, when we start talking about mitigations early on, it's really good to have, even if you are going to do beyond visual line of sight, because often we utilize extended visual line of sight as a mitigator for some of those beyond visual line of sight operations, which we'll talk about as well. And beyond visual line of sight is where the flight operations are beyond that remote pilots, where they can visually see. And you're using the risk-based approach to manage the air and the ground risk. So today we're going to talk about the workflow and all those components, because that will help you have that practical understanding of how beyond visual line of sight is going to operate. It also, if you have this fully understanding, you then can understand what equipment should you select, what sort of staff you can hire. So it's a really good idea to have this understanding before you start your operations. So there's a lot of components to put into a beyond visual line of sight safety case for you to submit that to CASA. So we're going to talk about the concept of operation, developing that, developing KMLs, developing the specific procedures for the tasks, the specific training required. We're going to talk a little bit about the SORA, well, actually quite a lot of it, because you've got to fully understand that, and also some of the additional paperwork that's required, such as an emergency response plan, HMI interface assessment, and stakeholder engagement. Usually you put all of those in information together, you start implementing the mitigations that you put in your procedures to your hardware and your software. You then actually need to start practicing it. So you need to conduct procedure, ERP training before you submit all your paperwork through to CASA, utilising the 10109 form, which is on their website. It then allows you to, once all the paperwork has been assessed, you can then book a flight test in, if it's your first beyond visual line of sight, where an inspector will come out, assess your procedures and how you operate and how your emergency response plan and everything will work before they issue an instrument. Usually instruments will last a year for the first time, and then you resubmit that 10109 every year when you want to extend that. I have seen some that have now got them up to 3 years as well. Jackie sort of hinted at the SORA and the supporting documentation. We didn't want this to be a SORA course, but it is one of the largest things and more complex bits of information that you're going to need to put together for a BVLOS safety case. So we thought it would be beneficial for you to understand that the SORA is essentially the specific operations risk assessment, and it's CASA's preferred methodology for assessing the risk of these complex operations. And it's been developed internationally by a group of experts. So the first step when you're looking at putting in a BVLOS operation is to define the concept of operations. And first of all, you need to figure out what is the purpose of the activity. So what's your goal? What's the aims of the mission? And then you need to select the relevant technical, operational, and systems information that supports that mission. So that's things like the hardware, the aircraft, the supporting systems, whether it's going to be LTE or what kind of communications link you're going to rely on. Other external systems like GPS need to be considered. And then who's going to crew this operation? What is the crew composition going to look like? What do you need, and what qualifications do the crew need? You need to look at, you need to consider your area. You need to put in contingencies and buffers, and we'll discuss more of that as we talk about a bit more about the ground risk. And feeding into that is the emergency response plan, which we'll go over in a bit more detail further towards the end. So because this is supposed to be a practical application of beyond visual line of sight, we thought we would sort of compare and contrast two types of missions that you might want to undertake, or fairly typical beyond visual line of sight operations. So one would be sort of a long linear asset like a power line or a gas pipeline. And you might want to use a powered lift type UAV, simply because it's got a small ground area for takeoff and landing, and then taps into the benefits of fixed wing for mission duration. Typically, you probably find these assets in Class G airspace, and the ground will be sparsely populated. And then the second situation that we considered was an industrial site inspection, which lends itself nicely to this drone in a box idea, where it's a highly automated UAV. The ground risk could be controlled, and you're facing atypical air risk, which we'll talk about more when we get to air risk. So to go over the types of aircraft we've selected for these missions, the power lift is an auto flight system. Our command and control link will be via LTE. And we have a maximum takeoff weight of 30 kilograms for this particular aircraft. The drone in a box type for the industrial inspections, we've picked an industrial grade autonomous system. Its command and control link will be radio frequency from the base to the aircraft, so more limiting than the LTE, but fits in with the concept of operations that we've defined. It's a smaller, lighter drone, so it only comes in at 10 kilograms. So obviously selecting the right crew to making sure you've got that. And also just want to go back to the concept of operations as well. A lot of people come to us and sort of say, well, they may have like, 50% of the ConOps done, but they actually don't know what airframe to do. So it's good that even if you are missing one component, to go through this process, because then it will help define to say, oh, actually, we don't have the right crew for this, or we don't have the right airframe, or we can then, hire the right people or buy the right equipment. So for Beyond Visual Line of Sight, the remote, currently in Australia, the remote pilots must have passed a theory component of the instrument rating or an approved BVLOS examination. They also must have a radio qualification. Currently, I do know Scott and Luke at many of the different AAUS conferences, they have come out. There is a Beyond Visual Line of Sight examination in the process, and I believe there was some little snags with needing to change some of the legislation. So I believe below 400 foot one may be coming out early or to mid next year for a qualification that people can use instead of the instrument rating.
So one part of the ConOps that needs to be considered is, what does the BVLOS operations area look like? Have you considered the environment that the aircraft is going to be operating in? What is the range of the C2 link? So we've got two very different command and control link distances. Possibly conducting a viewshed analysis is useful at this stage before you even go out and select a site, because there's no use. You need to consider where you're going to position your ground portion of the UAV system in its entirety. You need to consider your vertical and horizontal flight limits, how high and how far you're going to fly, and any one-to-one buffers that you need to put around that operational area. The one-to-one buffer needs to be the same level of ground risk as the operational area that you are operating in. Jackie will talk more about that in the next couple of slides. So the specific operations risk assessment as a whole basically looks at the input, or the concept of operations, what the intended mission is, who the operator is, and what does the crew look like in terms of their composition and their qualifications. The middle portion is then to determine the air and ground risk and come up with a level of total risk that needs to be addressed under the BVLOS operation. The output then will be all the safety mitigators, the procedures and training that you have in place in order to safely conduct that BVLOS operation. Next couple of slides are just a bit of semantics, so you kind of understand what we're talking about. Integrity is used in the SORA as the quality of a system that indicates that it can be relied upon to work correctly on demand. And it's expressed in many ways, typically failures per flight hour. Assurance is how do I know that that system will work? So if I give a low level of assurance, it's just that I'm stating that the system will work. A medium level of assurance is that I've got some sort of evidence. So I've either done some sort of testing and simulation, I've got some data to back up what I state. And a high level of assurance is where the integrity is acceptable by a third party, for example, a CASA audit or an audit by a QUT or somebody like that. And then if you put them all together, putting integrity and assurance together, you get this concept of robustness. So they have to sort of match up. As you can see, you can't have a low integrity system with high assurance and achieve anything higher than a low robustness. So it's just to give you an idea of what we're talking about in the later slides when we discuss the robustness of your mitigations.
So I'm going to talk a little bit about ground risk, and please note we are using a lot of the slides from the JARA SORA, one of the latest versions. I do believe a new version will be released very shortly. So these slides, when you go to do your Beyond Visual Line of Sight, they may be slightly different as well at that stage. So I want to look at how do we determine what is that initial ground risk? Like, what is it going to pose to the people on the ground? So we can break that into the intrinsic ground risk. We can break that into like controlled, sparsely populated, or in more of a populated area. A controlled environment is an area where the risk can be controlled. Let's just say for the scenarios that we gave you, it was like a power plant sort of situation. You know, only active participants are on that site. They've done inductions, there's usually fencing, security cameras, and it's a very controlled environment for that. A sparsely populated it has different meanings. I guess if you're probably the CAA compared to CASA have a different, amount. We did notice through reading all the standard scenarios that it usually was defined as less than 10 person per square kilometres, with dwellings no more than 100 dwellings for that area. Flip to that. We also we need to establish that intrinsic ground control. The operator needs the maximum characteristic dimension, either the wingspan or the blade or the rotor dimensions, and that's how we work out the typical kinetic energy for the impact and the intended operation for the scenario. So for these scenarios that we've done, where they are less than the 10 person per square kilometres, and we've got no dwellings more than 100, no settlements or dwellings more than 100. CASA does accept the population, ABS population density, so that's where we get all ours from. So for, we have done the kinetic energies for the 2 airframes for this scenario. So with the power lift being at 23.28 and the drone in the box, which was the smaller airframe, at 4.9. So what we would be falling into the column number 2. So the wingspan was less than 3 meters, with the kinetic energy being less than 34. So we have deemed that this is sparsely populated, so it's going to give us a rating of 4. They can't see my finger when I point to that. And look, if we were to say a controlled ground environment, it would be a 2. So when we move to that, so that's our initial thing. We obviously want to lower that as low as possible, and we'll get that when we get the sail level, or we'll then need to go back and change the concept. So we need to put mitigations in place to lower that. So the mitigations for like M1, for example, it's to assess the effectiveness. You need to consider things such as the ground risk buffer, the results in the ground footprint, or evaluate the people at risk. Possible example is putting a buffer in place. So a lot of the scenarios you will see that they do say like a 1-to-1 buffer. So that's if you're flying at 120 meters, the buffer would be at 120 meters. You could also claim a lower population density, by chronologic. Example is industrial estates at night or residential areas during the day and things like that. Please note as well, you can't lower, let's just say we're doing an M1 and you wanted to try claim a minus like 2, and you're already at that controlled. If we flick back to the last one, you can't go lower than what's in controlled. So let's just say we're already at the lowest for that column in 3 meters. You can't actually make that risk any lower. But if we were already BVLOS and sparsely populated where we started 4, yeah, we could mitigate that down to a 2. So M2 is the effects on the ground impact are reduced. Some of the things that we're sort of seeing people put in their safety cases could be such as an ASTM standard parachute, which might be able to claim a -1. And also an emergency response plan. This is the only one where you actually go up. If you don't put an emergency response planning, hence why we'll talk about it a little bit later, you'll actually get a +1, so your risk goes higher. So we are finding most people it is definitely worth a medium. I'm not seeing many high being achieved in Australia as of yet. So for this scenario, we're going to say that we start off an initial ground risk of 4. We're going to put the mitigations in place for this scenario. We're going to have a 1-to-1 buffer. So we're going to have 1-to-1 buffer, and we're going to put an emergency response plan in. So we're going to have a final ground risk of 3 for the ground risk.
So if we talk a little bit about the air risk, that's part of the risk assessment that needs to be covered under the SORA. We've got the industrial site inspections, which is a typical airspace. And then we had the powered lift or the long linear asset inspection type operation in Class G airspace. So we've defined our area, and we've had a look at the air charts, and we've noted that we are in Class G airspace, and there are no adjacent Class C or D airspaces and no military control zones without aerodromes within 3 nautical miles. So our risk, when we consider the air risk, is fairly low. getting back to the atypical airspace, how it's sort of defined very conversationally is that it's the type of airspace where manned or crewed aircraft cannot go. So anything within 100 feet vertically of buildings or 120 meters horizontally, we've seen come out of the CASA standard scenarios would be considered atypical airspace. So the air risk rises in airspace where you have higher densities of traffic, because what you're assessing for is the possibility of a mid-air collision with the crewed aircraft or manned aircraft. So the more highly used, with high traffic densities, the greater is the risk of that airspace. So controlled zones, things around aerodromes, airspace on approach, that kind of thing, will be heavily used and be considered very high airspace, high risk airspace. But what we can actually do is we can put in some strategic mitigators to bring that air risk down. And there's sort of two types. Essentially, you've got operator restrictions, so you can restrict your operation based on geography or timing. So for example, if we look at these air routes feeding into Brisbane Airport, you can see that the approach and departure paths are heavily used, but there's not a lot of crew traffic using either the parallel ends of that runway towards the side. So in theory, you could make the case that the traffic density in those areas is actually more like Class G airspace. But any mitigation that you claim for this does need to be backed up by data, which is somewhat problematic to get hold of at this stage. The other method of putting in a strategic mitigator would be, for example, restricting the time of your BVLOS operation. So if an aerodrome or an airport has noise abatement or curfews in place, you could operate in the departure and approach paths at times when the aircraft's not using it, because they're actually not allowed to be using the airport at those times. That's just a sort of a general rule, but again, that does need to be backed up by data and other approvals. So it's not necessarily a quick fix at all. Another potential mitigator is to conform to the common rules and structures that already exist in the airspace. So what we're talking here is things like filing and monitoring NOTAMs, flight plans where possible, high conspicuity of your UAV, strobe lights, things like that. Any electronic cooperation means some sort of detect and avoid system, and obviously the use of VHF communications with aircraft on the established frequency. Those sorts of things can reduce the air risk that you're facing. But the issue with that is that unless you're operating in atypical airspace, you always face some sort of residual risk of a mid-air collision, because manned traffic are using that airspace. So what's required from the SORA is this idea of tactical mitigation, and it's essentially that see and avoid, or in our case, detect and avoid idea, that there has to be some sort of operator feedback loop where you can detect intruding aircraft and you can put in place procedures to avoid them. So our example in atypical airspace doesn't require this because there are no manned aircraft. But if we look at our long linear asset inspection type example, what we could do there is it's Class G airspace, so the risk is low anyway. But we would still require the operation to have some sort of detect and avoid scheme, and that could be procedural based. So you could use commercial off-the-shelf products like Flight Radar 24 that relies on ADS-B. You need to detect 50% of the traffic in that volume, and then you would put in place procedures, for example, to descend to not higher than the tallest trees or buildings in that area within certain timeframes.
So we're going to talk about the specific assurance integrity level, and that's when we've worked out what our ground risk and what our air risk is. So if we join that for the air risk that Nicola said, we've actually got that down for that scenarios, it will actually be the air risk of B. And our final ground risk was going to be, I think we've highlighted the wrong areas. That's fine. It's actually going to be a 3 for that, because we're only going to use a -1. So we're going to have a sail class of 2. So you often hear sail 1, 2, 3, 4, 5, 6. And this is where, once you get this, even if you don't have the full ConOps together, this is a really good thing to get to. So if you tell me that you want to fly in the middle of Brisbane, you're going to fly an 8-meter wingspan drone. What we can do is then quickly assess that, oh, it's going to be a sail 5 or a sail 6. Look, in Australia at the moment, most BVLOS operations are sitting at a sail 1 or 2, and we're seeing more come into that sail 3. I don't believe, correct me on this, I don't believe anyone has currently got any higher than that through the regulator as of yet. So if you were to do your initial assessment, it comes up as a 5. The reasoning why, which Nicola will talk in a minute, is we've got to have such high level robustness, and not all of those systems and procedures are in place in Australia. So if you do get that, you've got to go back and you've got to work out, well, how can we lower that air and ground risk lower? What mitigations can we put in? Should we add that parachute? Should we add that 1-to-1 buffer? Do we actually need to do let's pick a new area just for the first trial phase and move that in. One of the long linear inspections that we're talking about, got a lot of energy companies at the moment wanting to do like entire state, like power line inspections, for example. Now, each of those have different risks for the area. So it's good to break down to say, right, we might start phase 1 as doing everything with this risk level. Phase 2 might be a higher risk level and work up as well. Because it is very feasible at the moment for a 1 and a 2 in Australia, but the higher you get, it's definitely a lot more complex, and it will cost a lot more money and a lot more time with the regulator as well.
So we've looked at the ground and the air risk, and we've come up with an overall risk rating for our BVLOS project or mission. And now what we need to do is put in place those safety mitigators or defenses to the hazards that we face in order to ensure the safety of the BVLOS operation. So we've got sort of 4 key areas where hazards can arise, and this is based on the SORA, so it's based on that collected experience of a group of worldwide experts. Some of the dot points underneath, you'll see them in every sort of environment or every sort of group of hazards. That's because they basically do more than one thing. So your procedures for your RPAS technical issues could be around pre-flighting and setting up and making sure that the aircraft is in fact operational. But you also have procedures that trap and confine human error and allow the operators to assess the environmental conditions. How do they know whether the operation can be flown with the weather that they're facing, and how can they interpret a forecast to know that the operation can continue safely throughout the duration of that mission, particularly if you're airborne for several hours at a time. Other things that feed into RPAS technical issues is things like maintenance that will form a barrier against that top level loss of control of the BVLOS operation. And you need to consider your command, control and communication links. So we've taken an extract of the operational safety objectives matched up against the sail level. As you can see, this first part deals with the technical issues surrounding the UAS, and we have the sail levels towards the right-hand side. So you can see with an increasing risk profile, your robustness of each mitigator increases as well. So for some of them, sail level 1, for example, ensuring your operator is competent and proven is optional at a sail level of 1, but you need a high level of robustness for that mitigator when you get to sail levels 5 and 6. Yeah. The last sort of step of the SORA is to look at containment, and it basically is, if you consider a single probable failure of any part of the system, whether it's the aircraft, the supporting systems like LTE or GPS, or power plant failures, rotor and motor failures. What is the degree of your operations ability to contain the RPAS within the operational environment? And mitigators to this, a lot of these UAS have geofencing and return to home capabilities built into them.
So we're going to talk about, so the SORA was just one component. So we've talked about the concept of operation and the SORA. So there is additional paperwork required. A lot of that additional paper was highlighted in the safety objectives that Nicola just spoke about. So to meet some of the safety objectives, you've got to provide some more data. Now the more complex it is, the more data that you, or technical data that you will need to provide. So the information we're going to give you on the next few slides is based more on the SAIL 2 category, which I believe a lot of the CASA standard scenarios were based on more of that SAIL 2 category. So we're just going to go through those. So it's really important to develop. The one thing when you move to beyond visual line of sight, it's really important to understand your RPA, how it works. You've got to know that manual inside and out. People always say, look, oh, we've got this drone or we've made it. And one of the first questions I ask when a client comes to us is, does that manufacturer, that OEM, provide a manual? Do they provide an operations, like operating manual, and do they also provide a maintenance manual? Without those manuals, it's really hard to get a beyond visual line of sight approval through, because we need to know exactly like how the drone is going to actually operate if something happens, like if it loses signal, or if you get to put the parameters in, what have you got that set up for? So it is really a jump up that you've really got to fully understand your equipment and how it operates. So developing the task procedures needs to include things like your RPA operation limits, the limits and supporting of the external systems as well. So if you're using like LTE, you've got to sort of understand the limitations for that area and the signal strength, etc. Weather and environmental conditions as well, how the remote crew declare themselves fit to operate, and how the remote crew is assessed as current and competent. And also you'll need to provide the current list of remote crew members. One of the things that we need to add in the procedures as well, and this we usually have to spend quite a lot of time developing these, or if hopefully the OEM that you're working with has a very good manual that you can get a lot of this information from. But you need to understand, like, what are you going to do for airspace incursion, or if there's low fuel or battery charge, or you've got failures of the engines, or you lose your C2 links, or it flies away, or or you lose VHF communications, GPS loss or failures, or something happens to your crew. So you need to have very, very good detailed emergency procedures, along with how you're normally going to operate. So are you, like when you're on site, are you doing a visual check, or does your actual RPA or drone do the pre-flight on its own? Like, how are you going to launch? Like, what procedure? Like, how are you going to check the airspace and the weather? Like, how does that all work together? Also, how you recover, and also your post-flight fee procedures as well.
So part of what's required for the application as well is charts and maps and things like that. This is the data that supports where you're going to conduct your BVLOS operation. What's really useful are these KML files. You can create them in Google Earth Pro. It's free use and can be read by almost every geospatial software. There is guidance provided by CASA on their website about what needs to be included in the KML file, things like where do you plan to locate the base station, where your buffers are, what your alternate landing locations will be, and any dwellings that you plan to create as no-fly zones.
Yeah, that's one recommendation. I mean, I know that a lot of people on the call have been operating for a long time, but if you haven't gone and checked out the CASA website lately, they did update it a few months ago with the beyond visual line of sight, and they've given a lot of guidance of information and templates for a lot of the things that we're about to talk about, and just quick links and some suggestions as well. So it is really beneficial to jump on their website and have another look.
So we talked a lot about this emergency response plan and what it needs to and why it's important and why it reduces, gives you that reduction in your ground risk. So what it needs to, what an ERP really needs to look like, it needs to be specific to the area that you're going to operate in. You need to understand what's going to happen when a serious accident incident occurs, and how those procedures are going to operate. And you don't get really much benefit if your emergency procedures are at a low level of robustness. So, and in order to achieve that medium level of robustness, your procedures for an emergency need to be well defined. Your equipment needs to be available and appropriate to the type of RPA that you're operating, and in the type of environment that you're going to operate it in. The way to achieve assurance for a medium robust emergency response plan is to have validated it through a tabletop exercise. And again, all RPAS personnel need to be trained on these procedures. The human machine interface assessment is essentially an assessment of the human factors aspects of your RPAS operation. So you're considering things like operator fatigue, their ability to read and understand the information that they're given on the screen. There's nothing confusing and nothing that could cause or introduce error into the operation. And then what's also really important is the stakeholder engagement with airspace operators. So particularly if your adjacent airspace has an aerodrome or an airport next to it, you might not be operating right at the airport, but you need to consider that adjacent airspace. Other stakeholders that you might want to engage with is the Air Force, national parks, and other private landowners that the BVLOS operation could affect. You need to contact the stakeholders before you undertake the BVLOS operation, just so that there's a good level of engagement, and if there are any objections or requests that need to be made of you, then you can accommodate those before you start operating. The training needs to be undertaken whenever you introduce a procedure. You need to set out your theoretical and practical training syllabus, and you need a check flight profile. Again, because it's training, it needs to be recorded in line with all the other types of training that gets undertaken. And there needs to be an internal training syllabus that supports BVLOS trainers, along with your emergency response plan training syllabus.
So I'm going to quickly talk about, CASA did release 5 Center scenarios a few months ago now. So I'm just going to quickly go through those. So one of the first 3 that they've done is more atypical airspace, like we've talked, where it's 100 foot from the structure. So near a vertical object over a controlled ground environment, which we did discuss earlier in the ground risk. And also the second one for Center Scenario 2 is a vertical object over sparsely populated ground environment. Now, this one could be utilised in the scenarios that we talked about, even for the long linear, if you're doing the power line inspection of gas plant, but within that 100 foot or near that vertical object, you could easily fall into that for the scenarios that we've given. The third one is in the remote area within 3 nautical miles of a registered or non-controlled aerodrome. This scenario, I believe, is very suitable for mine operations. So it's very remote Australia, which we know there's lots of mine operations, but usually at those remote sites or even the large agriculture farms, there's often a non-controlled aerodrome to bring those fly in and fly out workers in. So that Standard Scenario 4 is very suitable for that. We just had a poll pop up. Let's quickly stop that read. Do you believe the CASA standard scenario for BVLOS will assist the industry? So if you update your poll, I'm going to tick yes. The last 2, look, the SORA is only a guidance for regulators. So how the CAA or different regulators from around the world interpret it is entirely up to them. Australia, we're very advantaged. What makes people come to Australia to test and to do beyond visual on site? The one thing is we have very low air risk. We're a very large company. So CASA did create I guess, additional air risk classes, and we call that very remote Australian airspace, which is very similar to a typical airspace. So the last two scenarios are based that. So it's very remote Australian airspace. They talk about the J curve. So if you are interested to know, is your airspace that you want to fly in that new remote Australian airspace, if you go onto their website, there's something called the J curve KML, and then you can overload that onto your KML file and you'll see if you're in that airspace. So the last two scenarios are based on that. One is below 400 foot, and the other one is above 400 foot, but below 5,000 foot AMSL. So how the scenarios work, the CASA's done, well, the hard work, I guess, for you, but it doesn't mean that they've done all the hard work for you. So what they've done, they've developed a concept of operations, then they've gone through and looked at the risks by utilising that SORA methodology in the same way that we've just gone through looking at air risk, ground risk, but they've given you examples of what the mitigation will mean. Oh, I think we've got the poll. So yes, just to let everyone know, with the updated poll, it looks like 79% believe the standard scenarios will be useful, and only 1% no, and the rest are maybe, but they need access to more scenarios. So what they've done, they've come up, you might not know, when we're talking about the mitigations, you might not know, well, what is a -1? Like, what do we actually have to do? Like, how do we know that a -1 in M2 is an ASTM standard parachute, or, even if it could be a power lift drone that utilizes different like battery sources to operate. Like, there's all different measures it could be, but you may be not aware of those. So what they've done is created and solve some of that risk for you in a way that if you follow this sort of prescriptive method and provide the evidence they've done, that you've fallen and covered all of their risk associated. So on their website, they've given application guide. So each of the application guides and the evidence that you have to fill in matches what we've just discussed in that SORA. So that you'll need to provide like an emergency response plan. You'll need to provide a KML file showcasing that you are within that structure, or you do have a one-to-one buffer. So that's sort of, how that works. I believe at the moment, just after talking to one of the inspectors last week, they have got one scenario come through, so they're currently assessing that. We're hoping it definitely changes. It'll allow a lot more people to enter the market. We're also hoping it helps with the wait time. So currently, and I'm not saying the flight test it's been a bit all over the place with COVID lockdowns and restrictions, but usually we're sort of seeing people between 3 and 6 months wait. But hopefully with the scenarios, we'll see a cheaper sort of option, because it'll take less time for the inspectors to inspect that. And also hopefully a shorter wait time as these fully integrate into the BVLOS. So the last slide before we sort of move on to questions is, well, what's sort of next? Obviously, beyond visual line of sight is great. It saves you moving, along the power lines every 400 or 500 meters, entering to people's properties and different things like that. But to get that value add and to be more cost effective, the things that we're going to start to see is one-to-many. So what that means is you've got one pilot flying multiple RPAs at once. So we're starting to see that definitely become more popular in Australia. A lot of the agricultural companies are starting to fly, one drone to, so one pilot to 5 drones at once, for example. And even some of the drone deliveries, well, they might be flying up to 10 or 15 drones at once. So I can only see that increasing. The big thing that we're sort of seeing as this moves forward, and we're definitely seeing more highly automated, drone in the box styles or they've got automatic battery charging and things like that, and they're becoming very popular in Australia, is remote operations. So that would mean setting up to fly from your office or from a command center. Hover does have one of those, and you could be flying from your office through a drone that could be in a different state or a different site from where you're located. So we just skip through. That's just a little bit of information about us. But yeah, Greg, if we sort of move forward to some questions.
Terrific. Well, thanks, Jackie and Nicola. That was a very informative 40 minutes of BVLOS. I hope people have been able to remember everything you've just talked about there. So some great advice. We've got some questions coming through. The first question at the top is from Mike Roberts, who's asking about licensing qualifications for BVLOS to replace IREX. And you mentioned it a little bit during the presentation, but his question is, has there been any movement from maybe industry or the CASA perspective on some changed licensing requirements for beyond visual line of sight?
Yeah, look, and I'm fairly outspoken on this. Like, I don't believe the IREX requirement is fit for purpose. And look, I know the AAUS and different industry bodies have sort of spent a lot of time on different working groups with CASA trying to create something that is fit for purpose. I do believe, as I said, I know that one of the recent AAUS conferences, like Scott Duffy, and I think Luke has also gone out and said that they have developed an examination that they are hoping to release. I do believe there was some legislation changes that they needed, so I'm not sure how timely and how quickly that can happen. Look, that's just the first step. I do believe that it is for less than 400 foot, so it would be more appropriate, but it would go into things like, the C2 link, things that you may not actually learn in your instrument rating as well, and trying to keep below that, the 400 foot. I mean, over the time, there'll need to be more and more developed for the different operations as well. But I don't have any more information than, unfortunately, for this year, you will need an instrument rating to pilot. The one thing that they did release as well, just for those of you who may not be aware, you can now have, let's say, look, I'm not an instrument rating pilot, but Nicola is, for example, and let's just say we were flying, I could actually be the remote pilot and operating that airframe, and Nicola could be there managing as that instrument rating person. So it does allow people that do not have that qualification, that instrument rating pass, to actually operate beyond visual line of sight, as long as the remote pilot in charge or the supervising pilot does have that. So that can be quite useful as well for some organisations.
From your perspective, Jackie, just picking up that thread of conversation, what do you think are the most important skill sets for an operator? Is it experience, or are there some certain bits of knowledge that are required for someone to go away and operate safely beyond visual line of sight?
I mean, I'm not saying instrument rating is completely useful. It's actually, that's more done in the planning stage. So it's really important to understand the airspace and the whole environment in that planning and, doing the SORA component. When you're actually the pilot in command, it's really important just to, understand procedures and understand your RPA and what's expected for that, to sort of, like if you do lose C2, well, how does it actually work? So how does all those components work, and really trust your system? So it's, a lot of practice and a lot of training. But it's mostly on-site practical elements.
I agree with that. Yeah, definitely.
No worries. All right, we've got a question here from George. It's been voted up a little bit. And I believe that the question is around the SORA process, and if it could be used for larger drones, as he's quoted here specifically around 300 kilograms, for the purpose of goods delivery. So how applicable is that SORA process for the larger drones?
If you can mitigate it. So, I mean, there was that column for the larger RPA. So yes, but your ground risk is very high. So it's a high thing. So if you can't mitigate that, so look, at the moment, it possibly could be feasible for very remote Australian airspace, like you're flying out of the Northern Territory or middle of Western Australia, you probably could. But if you're going to fly closer to sparsely populated or more to a city, your risk will be too high that it will take you to beyond what the SORA can manage, or it'll be very high robustness, which is not a lot of procedures in place. So it might be a better path to look at certification. There are a lot of sort of work being done in that regulatory roadmap and how that future is going to look. And the AAUS does sit on a lot of those committees with the Department of Infrastructure, if it's CASA, on the regulatory working groups. So a lot of that is trying to develop. But at this stage, I'd say if you're going to do something large, you probably need to look at where it's low ground risk and low air risk.
No worries. There's a couple of questions, just some clarification around the BVLOS licensing. The first one's from Alf McMillan, picking up on your example before with Nicola as the instrument rated pilot supervising yourself, Jackie. Does that person who's being supervised need an REPL in that scenario?
Supervisor? Yeah. They need to be qualified and trained on the system as well, because really in the scheme of things, like if something happens, they are the remote pilot in command. So yes, they need to be fully licensed on that actual RPA.
Okay, and just another one on the similar thread from John Morrison, asking, this is looking at the future BVLOS test. Has CASA offered any ideas on how an operator prepares for a BVLOS flight test / assessment?
Yeah, like I guess like, you know, the visual line of sight and the EVLOS, or if you're flying, they do give guidance. So when you complete your desktop assessment, they do send out guidance of what that scenario. So you do have plenty of time to practice. But usually if you've written the procedures, they go through everything from, you know what, how are you going to operate? How are you going to plan? So to make sure the maximum limits and that you haven't breached the maximum range. Then they do spend a lot of time on emergency procedures, like what happens if your computer goes flat and your RPA is that many kilometers away, like what's actually going to happen. So there's definitely is guidance out there from CASA. I don't believe it's open, like I've never seen it on their website, but I do know that you do definitely get that when your desktop assessment is completed.
Good. Question here from SUAS Rove. Hi, Jackie and Nicola, great talk. Can you comment on the costs associated with BVLOS approvals, please?
Yep. I mean, this will vary on complexity, but the cases that we're given, we're sort of seeing the initial charge of about 2,880. That's sort of the initial charge. Now, for BVLOS, we're not really getting it back because that usually does include like a CASA flight test. If all your procedures and that are not in place, it could be back and forward, and the inspector might need to read that 2 or 3 times. It might go up slightly. Also, if you're going to go in and try to do a sale 3 or 4 or 5 or something like that, that will not be the cost of it. There's obviously a lot more time and work that might need to not go from the normal RPA inspectors. It might need to go through to different airworthiness teams in the department, so it like involves extra people. But it's a good guidance at the moment, 2,880. Look, usually there is a fair bit of work to put all the paperwork together. Like if you were to get a company or an organization to do it, there's sort of like, 9-10 days sort of work to put all the information through together. You want to allow at least sort of $16,000 to $17,000. Might not be if you're doing it yourself, it's not going to cost you that much, obviously, but you want to allow that either that time or that money.
Yeah, so I guess that investment in time is largely within your own organisation, if you have the capability to run through that whole risk analysis process, or using a consulting company like yourself. There is investment there on top of the CASA costs. Yeah,
it's really important. Where I see costs and go out, it's really important to have a full concept of operation. So you have a planned concept, you work out your sale level. If you believe you can't meet that sale level, go back, change your concept of operations. But all of the procedures and all the work that's created is from that concept of operation. So if that changes 3 or 4 times, like even when that's with inspector, that's when things go out, because everything then changes. It's like a flow and effect.
Okay, so just picking up the thread about the types of operations that are getting approved here. You mentioned sort of relatively low risk operations are getting through at the moment, and I think you have some stats on how many BVLOS approvals CASA have done in the last 3 years or so.
I do, but I can't remember what it was. Again, I didn't tell you.
You told me yesterday that
I think it's 128.
120 approvals since the start of 2018.
Yeah.
From your perspective, in those sort of approvals that you've been involved with, what are the typical types of use cases that you're seeing? Are they more regional, rural areas below 400 feet, or are they over populous? Are they higher in altitude? What are you seeing as a general rule?
Class G airspace, possibly with an adjacent aerodrome, and remote or sparsely populated ground risk that's under 400 feet is definitely very common.
Yeah,
very popular.
I mean, and I probably can talk about it. I know Renee's not on today, but she's going to watch. Like you know, Department of Horticulture just got theirs through a few weeks ago, and you know what, it's flying in very rural or remote areas. The airframe itself is very wide and varied now. I'm sure you've got, you know, from that definitely high end scales where the RPAs be like, you know, $250,000, but we're sort of starting to see, you know, what some of the DJI products or, you know, some of the Fox Techs or, you know, $20,000 VTOLs get approved as well, which is really good.
Excellent. Well, we've got some questions coming through on systems. Here's one here from Cress, who asks, we are developing payloads intended for deployment on BVLOS RPAS in the future. Is it better to develop for a drone in the box system from the outset, or to do BVLOS on a simpler RPA first? So I think he's asking the crawl, walk, run approach, maybe.
I mean, definitely, you know, that drone in the box style is definitely sort of the future for large deployment for security or, you know, even agriculture and things like that. You can still crawl, walk and run with the drone in the box style. You don't have to start with remote operations. I mean, you can, you know, it can be doing extended visual line of sight with that, which is a great step, and then move to that beyond visual line of sight to practice those procedures and then move away. We are seeing, look, the drone in the box there's some great options out there. Some of them even utilize, like, you know, off the shelf commercial drones with, like, you know, for a few $1,000s on them as well. Yeah, look, it depends on, I guess, what the ConOps is.
Yeah. I was going to say that as well.
Yeah, like drone in the box is not going to work for long linear to my, like, to start with, but it's great for you know, a sewage treatment plant or something like that.
All right. There's a similar question here from Stephen Young. If developing and building our own drones with the intent to be suitable for BVLOS, are there any guidelines for components? Using those major components with engineering/industry specifications provided is an obvious choice, build logs, etc. Is this quite feasible? So I think the question there is sort of heading towards certification. Is there a better way to build a drone that might help with lowering risk within the SORA process? I think that question.
I mean, I'm happy to extend probably offline this one because it's quite an in-depth project of like certification of an actual airframe. But where I would sort of say, if you're trying to even integrate different components onto an RPA or for a high level, often when we've helped OEMs come into Australia, we get them to do a deconstructed SORA. So we almost look at their manuals and what their systems and what they have on the RPA and break it down to say, right, at the moment, your equipment can get a sale 2, but if you add this, this, and this, you could get a sale 3. So there is definitely that methodology. Obviously, the higher the risk level is, the more you need on that actual RPA. So it is really good if you're building something to try and build it to a level where you go, right, we're going to be agricultural people. We know that we need to at least meet a sale 2. So these are the technical design elements that we're going to need on the actual RPA.
Terrific. I've got a question here from Ben, and I note in the Q&A log that Tom Putland, who is one of Australia's
thanks, Tom.
has also started answering the questions online. So thanks, Tom.
Thanks, Tom.
Appreciate the input. But I'll ask you guys Ben's question anyway. Are there any considerations towards guaranteeing an acceptable safety threshold when describing risk? For example, posing a probability of less than 1 in a million chance of impacting an individual. In other words, are the rankings provided loosely based on such absolute levels or relative to other BVLOS operation alternatives? That's the first part of the question. The second part.
Tom's great to answer that.
What scope is there for quantitative risk assessments within the approval process?
Yeah.
Are we just going to leave that to Tom, or do you want to have a go at that one?
Well, yeah, I mean, I'm not sure there's a lot more to add to what Tom said. And it's possibly beyond the scope of this discussion here, but sure, if Ben wants to get in touch with us, I'm happy to chat to him at length about risk assessments and stuff like that. It's what I do in my free time anyway.
Okay, excellent, thank you. Let's pick up a question here from Con. Hi, and thanks for the overview. My question is more in line with EVLOS, not so much BVLOS, and specific to close range. Which questions just go on there? Is the EVLOS an acceptable instrument to look at for populous area operations?
So yeah, EVLOS you can operate in any environment. So if it's, and I'm gonna break it down. So I know we've talked about, controlled, sparsely populated or populated environment. They're still very different. So yes, you can do EVLOS in any environment, but there's still a regulation that you cannot fly over a populous area. So if you want to fly over people, for example, or fly up to, a few meters from people, you still need to get an exemption to the regulation. So yes, it can be used in a populated environment. Let's just say you wanted to do, in the middle of a city, there could be a shipping container port or something like that, and you want to fly EVLOS there, where you know that, yep, you can still manage and keep 30 meters away from people. But if you want to start flying down the main street of Sydney or over people, or do delivery or anything like that with EVLOS, you're still going to need to provide further data to get that populous area exemption.
Excellent, thanks for that. There's a question here from Mark that sort of relates to learning of previous experience from other operators. And Mark asks, will there be a database of areas of previous BVLOS flights in areas that you may be operating? As BVLOS expands, utilising others' experience in certain areas would be beneficial. So can we learn from others in this context?
I hope so. I do know a lot of people that have put beyond visual line of sight. Some of the larger organisations that might even be flying like drone delivery, that they're always sort of open to saying, well, CASA can utilise. There's always got to be a first person, and we hope that the work that we might do or another company might do is utilised again to streamline and push the industry forward together. There's probably not an open database like information to the general public, so it's more the regulators that can. I think most people are happy for it to be reused and to work together.
I think the best source of information is those standard scenarios and the CASA applicant guides. They give you a really good sort of portfolio of what you've got to put together for an application in terms of learning from others.
I mean, yeah, and it's just connecting through. I mean, over the time we've sort of developed a little Bible of what each mitigation's been approved and what OSO, what we know is acceptable for a medium or a high and things like that. But that's to sort of come with experience, but I don't believe there's anything out there in public at the moment.
No worries. There's another question here from George. It's voted up to the top at the moment. Thank you for answering the previous question. Could you elaborate on the systems out offer, detect and avoid?
Well, we should actually, it's pity we can't bring Tom into it because they're doing, or if Terry or someone comes on, because they're doing a lot of work on that area now, but we'll high level ask, or we can always connect them through to a lot of the people that are starting to set the standards. There has been one of the companies in Australia that has been, won a contract to start developing a lot of the standards for that. So happy to connect you through to them. I know Greg can as well.
There are those systems like Iris Automation that does aircraft-based detect and avoid and ground-based systems. So you've got, if you have a fairly contained BVLOS area, you can have ground-based detect and avoid.
So it's a good point, Nicola, the ground-based detect and avoid. So for me, that says that you're in the airspace with cooperative aircraft. So those aircraft that are telling you where they are. And, you know, a lot of operators currently using ADS-B in as a mechanism to mitigate some of that risk, but not everyone out there is participating with ADS-B. ADS-B out. This is particularly from manned aviation perspective. How much do you think it would improve our industry's ability to perform BVLOS if everyone out there in the manned aviation space was transmitting ADS-B out?
I'm 100% for that.
So am I.
And I think that at the moment, I'm not really sure what the roadblocks are. I know there's cost, but I think the biggest roadblock is buy-in, because that sort of thing could be easily funded, where you've got those manned aircraft that aren't cooperating to be radio equipped and transponder, or actually ADS-B would be better equipped. Absolutely, and it's not just beyond visual line of sight drone operators that want it. I know for a fact that RPT operators also want them to get on board. We've heard it here first.
Yeah. we actually joke around some of the BVLOS areas that we work on. We go, oh, well, like for the Christmas present, maybe we actually all our stakeholders, that's what we give them for Christmas. But in your aircraft.
All right. Well, we've got a couple of questions. Just finishing up. We'll probably be done in the next 5 or so minutes, just for everyone hanging on out there. We notice we've still got good participation. There's still 111 people out there, which is fantastic. Corey Roberts asked a question around EVLOS. Is using EVLOS for FPV using goggles an easier scenario, and what costs would be associated with this?
So FPV, I'm not going to talk drone racing, because that does fall into a micro category, which it's a whole new category. I'm not sort of really well super equipped for that, but I do know CASA have a recreational team. It might be better to go through that. But I mean, you can definitely use FPV goggles. You can use binoculars, like for the spotters, for the extended visual line of sight. It's still the same process. So you're still going to have a pilot and a visual observer. So the cost will still be, the last EVLOS, it used to be 2,880, but I have seen that reduced. And I think the last EVLOS we put through for someone was about $1,400 or $1,500 for that application. That could drop if it's EVLOS Class 1, and it could go up slightly if it's EVLOS Class 2, because the CASA inspector requires a flight test for EVLOS Class 2. I don't know if that
you'd still need the observer though, regardless of the goggles.
Yeah.
All right, thanks guys. Last question here from Wade Langford. We define our operations area by way of describing them in 3D on paper. I note you refer to the use of KML files. I'm just wondering if you could please, comment more on this in detail, and how they can be used to define the operational area. So I think the question is around the use of KML files. If you could provide a little bit.
It doesn't have to be KML. The best thing is on the website in the scenarios, if you scroll down under the scenarios, there's the applicant, assistant, and it actually has examples of what a 4-dimension, to show what a KML flight looks like 100 foot above a power line, for example, and it says the exact same things, and it gives you guidance on how to do that. KML is just one we use. I mean, there's lots of different, and it's accessible to most people.
Yeah.
My way of thinking, when I have to sit and look at them, and so I'm sure from the inspector point of view, try to stick to what the color scheme is from what they actually recommend.
Yeah.
And don't create pink for green operational area, because it's just so much easier to read it.
Yeah.
But that is really good guidance in that document.
Terrific.
And Greg will probably share that, I don't know, at some stage as well. We'll make sure that links in there. I'll try to do it now.
All right. Well, great job, guys. We've actually got through the entire list of questions. Thanks very much for that.
There's probably just one thing that I want to add. So the AAUS does have like a SORA working group, which we are members of. So you know what, if you do have any questions or anything like that, or you need things pushed through, to sort of send that through to Greg, and he can get that to the group and we can go from there as well.
Yeah, thanks for mentioning that, Jackie. AAUS does have a number of membership working groups that all of our members are most welcome to participate on. The SORA working group, which Nicola and Jackie are involved with, is chaired by Andrew Duggan, and it meets quarterly at the moment. There's also a SORA issues register on the AAUS website. So if you do have any problems with SORA or anything related to getting complex operations approved here, please enter them in that register. The SORA working group will pick them up and attempt to come back to you with some help. If we don't know the answer, we can probably put you in contact with people that do. Thanks everyone for your participation today. It's great to see that everyone has stayed on pretty much entirely all the way through the end. It was a really great practical webinar. So thanks very much, Jackie and Nicola, for your really sharing your experience and knowledge with our members. These webinars will continue, and we hope to have one at least every second month, if not more than that, depending on what opportunities pop up. We're certainly looking for ideas for the webinars. So if you'd like to see something, please send us an email. We'll make sure we line it up for a future webinar. The next webinar we have lined up is with Wing Commander Kieran Joyce, who's going to talk to us a little bit about industry opportunities with Defence, as Defence try to improve their Australian industry capability in this area. So it'd be well worth listening to for manufacturers out there and indeed operators of our technology. In between that, we have an AGM, so everyone is most welcome to attend our AGM, which is on the 18th of November. If you're in Brisbane, you'll be able to have some food and a drink on us at the AGM, probably on that afternoon, in a location to be defined. For everyone else, you're most welcome to join virtually. We'll have Zoom links for the AGM as well. But thanks again for everyone for your attendance, and we hope to see you again soon. Thank you.
Thanks, Greg.
Cheers, Greg.